Hi, my name is Jenny Buckley, and I'm a professor of mechanical engineering in the Department of Mechanical Engineering at University of Delaware.
And my name is Amy Trout-Mayer. I'm the Associate Director of Science Education at the Professional Development Center for Educators at the University of Delaware.
We're really excited to present to you Find Your Center. The motivation for this lesson is that a beginning diver is worried about hitting a diving board when she's doing a flip dive. Students are asked to coach the diver through her dive, specifically to recommend how far from the board she should jump in order to clear it. In order to coach the divers, students will first gain a fundamental understanding of center of mass and how it affects the balance and motion of everyday objects, like a chair or a frisbee. We will then extend the concept of center of mass to the human body, using the example of our diver. Students will then conduct a biomechanics experiment to measure center of mass location on their own bodies using a do-it-yourself balance board constructed from wood planks and bathroom scales. They will then analyze their experimental data and draw conclusions to recommend a jump distance for our diver to clear the board during her jump. This lesson is best taught over multiple class sessions with 90 to 120 minutes of instruction time recommended. The lesson is appropriate for grades 7 through 12 STEM classrooms, including mathematics, physical science, physics, biomedical sciences, and engineering. Alternate presentations of mathematics and physical science concepts are presented in the supplemental materials to this paper, and it depends on whether students have completed Algebra 1.
The learning objectives for this lesson are to understand the concept of center of mass and how it affects the balance and motion of an object. Apply understanding to determine center of mass location in 3 different ways, namely the balance test, estimation using symmetry, geometry, and mass distribution, and the balance board experiment. Conduct a controlled experiment to measure center of mass location using a balance board on objects with constant and non-constant geometries. Synthesize data from human subjects experiments in both tabular and graphical forms, and draw conclusions based on experimental data.
So in conclusion, this lesson aligns well with the next generation science standards. Students engage with the disciplinary core idea of force and motion, cross-cutting concept of patterns, and they engaged in the science and engineering practices of planning and carrying out investigations, analyzing and interpreting data, using mathematics and computational reasoning, developing and using models, and constructing explanations and designing solutions.